Okay, good afternoon, ladies and gentlemen. I hope everybody is doing well today. So, today is a warm-up geared towards more of an EOC style of question, more of a kind of looking a little bit deeper type of question. If you were able to get this correct, you should be very proud of yourself. It is definitely not easy. Required quite a bit of higher level thought. So let's start out with answers. I'm not going to go to the equity bars for this because it was a high level challenge and I don't want to put anyone on the spot and make them feel badly. You shouldn't feel badly. So we'll take volunteers to start with. So we'll go Brian, Chris, Brandon, Sebastian.
S minus R.
The answer is S minus R. Okay, Chris? Is S minus R. So I had quite a few students ask me for some guidance, and I know sometimes it's frustrating because when you ask me that during a warm-up, I tend to not give too much guidance because part of the idea is for you to struggle through it. Part of the idea is perseverance. Part of the idea is sometimes it takes a little time for the ideas to kind of click for you. So what I asked those students to do was to go back to what sine really meant. And that was hard to interpret. You know, what is Mr. Gallo talking about? What does he mean? What does sine really mean? Could someone articulate what sine is at its most basic level? Dalton? Okay, so it equals opposite over hypotenuse. Let's go even more general. Sine is a what? Cosine is also a, and tangent is a. You can fill in a word there that all of them are. Alyssa? It's a ratio. It's a ratio. So here's how I think I could have made the question easier, but I intentionally didn't do it because I didn't want it to be easier. But if I had written this, I am willing to bet it would have taken you less time. I still don't think it's easy, but I think it would have taken less time. So let's go back to what Dalton said. You said that sine is what? Okay, so remember that the way the trig functions work is it's a matter of perspective. So when it says sine B, that means you're standing right there. That's your perspective. And that changes what opposite means. So opposite is now over here. So the sine of B is opposite over hypotenuse. And now that I wrote it like this, you can see that the R would have to be opposite, and the 1 would have to be hypotenuse. Now, when I did this question myself, at first I was very hesitant. I was like, I don't know if that's right. But as soon as I did the next detail, I knew I was onto something. Because now, cosine B. What is cosine? Saying it just like Dalton said, but he said sine. What's cosine? That word is adjacent, okay? Adjacent. But now, we're not over here. Our perspective is now over here. And, oh, I'm sorry, cosine B. I apologize. So our perspective is still here. Adjacent is now right here. Hypotenuse is still there. Adjacent over hypotenuse. Well, look at that. The 1 got placed in the same spot. Now it's starting to click. Which means that the distance from A to C is R, and the distance from A to B is S. That's all you need. Because now I ask you for the sine of C. If I had just asked you for the sine of C, if I didn't even include this, and I just asked you for sine of C, at this point you should have no issue. Sine of C. I apologize. So now our perspective has changed. We're over here. Sine is still opposite over hypotenuse. But now our perspective has changed, and so opposite over hypotenuse. So the sine of C, sine of C must be opposite over hypotenuse, so it's going to be S over 1. If that was it, you'd be done. But then I said, well, what would it be if we subtracted cosine of C? Well, we need cosine of C. Cosine of C is adjacent over hypotenuse, but now we're here. Adjacent is now the R over the hypotenuse. Cosine of C is now R. And I asked you to express sine of C minus cosine of C in terms of R and S. S minus R. So that in no way was easy, not even close. Took a lot of thought. The big leap, in my opinion, is understanding that right there and that right there, that it's a ratio. Okay? Anita. What do you mean if you found the hypotenuse first?
I don't know how, but I found BC equal 1, so then you just have to figure out what the...
I think that would make sense. How did you find it was 1? And then I'll get to Anne's question.
I don't even know. I missed it.
Okay. If you could explain it to me, I would love to hear it. Other than what I demonstrated here, I'm not sure how to find it. If you can explain to me, I would love to hear it. Go ahead, Anne.
Well, I had R minus S because I kept on thinking that to find sine and cosine it was an angle measurement, and then it asked me if it was a distance, and it clicked to me that was a ratio, so I put the 1 in the denominator for each of them, and that's how I got the answer because it makes sense.
Okay. But you said you had the letters flip-flopped?
Yeah.
Okay, do you understand why it has to be this way? Oh, okay, good. Good, I'm glad. Okay, Brandon?
AC over BC, and then I did the same with cos of B, and sin of B is
That's right. Yeah, and you're not the only one. So I saw a few papers that had that. So the sine of B would be AC. Sine of B would be AC over BC. And then you kept going, and you started seeing that the denominators ended up being the same, right? And then you're able to just eliminate the denominators, right? Is that what happened?
No, because I found the cos of B2,
Okay, the word is cosine.
cosine,
Okay, of what? Of B? Cosine of B is adjacent over hypotenuse, so we've got AB over BC. Okay,
and then I found the sine of C and the cos of C, and then when I did that, I was adjacent.
very good, very good. So you saw the connection once it was written out in this form. Excellent, excellent. And again, you're not the only one. I saw other people who had done the same kind of thing. Any other comments or questions? Any concerns? Any observations or theories? Okay. Our objectives today are to expand our understanding of quadrilaterals to start including rhombuses, rectangles, and squares. We're going to prove and apply properties of those 3 special quadrilaterals. And we're going to use those properties to solve some problems. So some new vocabulary terms that are going to be thrown around. They're not new, but new in the context of this classroom. Rectangle, rhombus, and square. You should have your cheat sheet out. We're going to refer to it quite a bit. Remember, the cheat sheet is there for you to use, but at some point, you have to allow yourself a chance to not use the cheat sheet to see what is making sense. So, we have our objectives. So what I'd like to do is take an overview of what we're going to be exploring today. So if you would take your cheat sheet and flip to the diagram, which I've cropped so that all I'm showing you is the parallelogram branch. If you would find that spot. So I tried to illustrate to you when we started the unit, or the chapter, that quadrilaterals and parallelograms are so important because so many ideas come from them. So we spent 2 lessons on just parallelograms and exploring their properties and then using their properties to prove that a quadrilateral was a parallelogram. But you can see that 3 major ideas stem from parallelogram. And so the one way to read this is that if you are a shape down here, you are a member of the family above it. So if this is a family, then the rectangle is a member of that family. And a rhombus is a member of that family. And a square is a member of this family and that one. And a square is also a member of that one and that one. 1 second. And so what is important to take from here is that every classification, every shape inherits the properties of its parent. The parallelogram is the parent of the rectangle, the rhombus, and the square, which means that a rectangle has all the properties of a parallelogram. But a rectangle has extra properties that makes it extra special. So let's back up for a second, and Dalton, I'll get to your question, so don't forget it. But could someone give me a property of a parallelogram? Any property that you can think of. Shelby? Very good. The opposite angles will be congruent. So this will be congruent to that, and that will be congruent to that. Since that is a property of parallelograms, that will also be true here. This will be congruent to this. That will be congruent to that. That will also be true over here. This will be congruent to this, and this will be congruent to that. These inherit the properties from here. There was a few other, give me another property, Catalina. So the diagonals will bisect each other. So if I draw the diagonal here and here, they will bisect each other. That is going to be true here and here. It will be true here and here and here and here. Absolutely. But then there's going to be additional properties. Alicia. The opposite sides are congruent. So this side, symbol. This side is congruent to that one. That side is congruent to that one. That is also going to be true here. And that's going to be true here, and it's going to be true here. Okay, Tristan? Opposite sides are parallel. That's really what separates parallelogram from other quadrilaterals. And so this is parallel to this, and this is parallel to this. That means all of these are going to have opposite sides parallel. But now today, you have to remember all of those things, but now include some additional details. Does anyone have any questions so far? And Dalton was first.
So this is all just like energy.
I guess that's one way to imagine it.
On the whole entire thing, not just the parallels, the the whole quadrilaterals, like all of the shapes belong to kite trapezoid or parallelogram except for one. And I don't know where that one.
Hold on a second. Wait, 1 second. Go ahead, I'm sorry. So only one shape is not a member of Were you looking at the bar that goes across the top? Okay. All right, we're going to get to it. Don't worry. That's why I focused on this branch. So all your questions about the other shapes is going to be answered. Okay? But you got to, this branch all goes together. Maybe one way to look at it is flip the paper over. Look at the Venn diagram on the back. That might answer the question for you. Okay? Any other comments or questions? All right, so now, the ideas that constitute the properties and differences. So on your cheat sheet, find the first three are corollaries. So, a quadrilateral is a rhombus if and only if it has 4 congruent sides. So, this is on your cheat sheet, so there's nothing to write down, but I want you to make a mental note of something. That this is written as a biconditional, which means that it works in both directions, forward and reverse. So, a quadrilateral is a rhombus if it has 4 congruent sides. If a quadrilateral has 4 congruent sides, then it's a rhombus. A rectangle. A quadrilateral is a rectangle if and only if it has 4 right angles. Written as a biconditional, then it works in reverse as well. If a quadrilateral has 4 right angles, then it's a rectangle. Here's one that is probably going to be a new perspective for you. Look at the square. A quadrilateral is a square if and only if it's a rhombus and a rectangle. I bet you never thought of a square that way before. I'll be honest with you, my 4.5-year-old son has known what a square is for 2 years. Since he was 2.5, his preschool teacher taught the students what a square is. But she said it has 4 equal sides. So he knows 4 equal sides, that's a square. You probably knew that when you were 2.5 or 3 years old. But now look at this definition. We're much more advanced than that. So this has to do with, again, the idea, like Dalton said, the family tree. The square is really the combination of 2 shapes that are above it in the family tree, which is the rhombus and the rectangle. If a quadrilateral is a rhombus and a rectangle at the same time, that's what makes it a square. Look at the symbols. You've got the 4 tick marks, 4 tick marks, 4 right angle marks, 4 right angle marks, all at the same time. That's a square. That's a very technical definition, but important.
So then, for the square corollary, isn't it kind of like how you would call something a regular polygon? Isn't it kind of like the regular square?
Can a square be irregular? What is the definition of regular polygon?
It's equilateral and equiangle.
And a square is? Right, but think about what you just said. Does anyone see what she's getting at? Because she's making an important point. But she's missing the connection. Can someone articulate the connection? Maria?
Square can only be a rhombus and a rectangle. I mean, equiangular and equilateral.
Yeah. Because what happens if I change one of these sides and make it longer? What happens?
No longer be a square.
It's no longer a square. So a square is always a regular polygon no matter what, because the definitions are actually the same. So I love that she brought that up. So a rectangle, what would you say about that and the term regular polygon? Brandon? That's right. So a rectangle would actually have to be a square for it to be considered a regular rectangle. Because if you look at this instance of a rectangle, that's not regular because these sides are congruent, these sides are these sides are congruent, but all four of them are not congruent. Okay, so that was a great observation and a great connection that she just made. Any other comments or questions?
Is that why a square can be a rectangle or a rectangle can't be a square?
Exactly. Very good. So now the theorems. And again, they're written as theorems, and I think they're all written as biconditionals, but try and get away from the idea of, oh, I have to name that theorem 8.11. I don't really care about that. It's the idea. And some of these ideas are a little bit harder than the ones we've explored so far. So let's start with the first one. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So that also works in reverse. But let's not worry about that so much. Let's just understand that if you have a parallelogram and you are able to prove or show that their diagonals form a right angle, then that means it must be a rhombus. If it's not a right angle, then you would just call it a parallelogram. The second theorem, a parallelogram will be a rhombus if each diagonal bisects the opposite angles. So this is showing that this diagonal creates two congruent angles, and it does it as well here. So now that parallelogram is a rhombus. Now flip it around. If I tell you that that's a rhombus, now you know that that angle is going to be congruent to that one. If it's a parallelogram, then that wouldn't be true. Watch. Let me go back to this. Let me move this out of the way. This is a parallelogram. Let me draw one of its diagonals. Does that look like it's bisecting the angles? Does that angle right there look like it's congruent to that angle right there? Definitely not. So that's a parallelogram. But if we go to a rhombus and I draw a diagonal, you can now tell that visually it looks like it's cutting that angle into two congruent angles. So that's a major difference between a rhombus and just a parallelogram. Any questions about that? Good. And lastly, a parallelogram is a rectangle if the diagonals are congruent. So that's an additional detail that separates the rectangle from just an ordinary parallelogram. Excuse me for a moment. I apologize. Any questions so far? Any concerns? Good, so let's jump in and start using these ideas. A sketch of the picture will be sufficient. Don't need to take out the ruler and start working with it. I'm just giving you a moment to sketch the picture. So I have two questions for you. First question, I would like to find the measure of that side. I would like the measure of TV. We are told that this is a rhombus. So we may use any properties that are unique to a rhombus or any properties that are unique to a parallelogram to aid us in finding that distance. Now, this is not a checkpoint, but I would like you to devise a strategy with your team just to answer part A. I don't want you to actually execute your plan. I just want you to come up with a plan. So take a minute to team talk and see if you can come up with a plan to find TV. Go. Come back as a whole group. Give me a thumbs up if you and your team were able to devise a plan that you're pretty confident will work. Got 1, 2, 3 teams, 4 teams. Good, put your thumbs down. Davis, what's your plan of action?
By the longest corollary, all the sides are congruent. So by saying 13b minus 9 equal to 3b plus 4. You can find b, then use b to find the measurement of one of those sides. However, that side, however long that side is the same length as TV.
That was an unbelievably outstanding explanation of your plan. I really appreciate that. That was great. You really covered everything. So I hope you were listening carefully to what he said. So we've got 3b. So now we're going to go ahead and execute his plan. Hopefully you and your team came up with a similar plan. If we set 3b plus 4 equal to 13b minus 9 and solve for b, we can then plug b back in and get that distance, either tx or vw. But he pointed out so astutely that tv is going to be the same distance because of the rhombus corollary. It says all the sides are the same distance. They're all congruent. So that was great. So go ahead and find B. Give me a thumbs up when you've got it. Just find B. Chris, what does B come out to? So B comes out to 1.3 or 1 3/10, doesn't really matter. And now we can plug that back in and find the distance. So TV will equal whichever expression you want to use. So go ahead and plug it back in. Give me a thumbs up when you got it. Oh, we got a whole bunch of people who got it. Good. Good. Michaela, what do you end up with?
7.9.
7.9. Dalton, is that what you got? 7.9. So TV is a distance of 7.9. Any questions about how we approach that? Any concerns? Any thoughts? Any observations? Go ahead.
Kind of for the second one.
Go ahead.
Part B. I think the angle in the middle, TZ to B, I think it's a right angle.
You think it is? Okay. So I'm going to give you a 1 minute team talk to now devise a plan for part B. Don't execute your plan, just come up with a plan for part B. I want the measure of XTZ.
That's parallel. Oh, okay, got it. I got you. So they're not equal to each other. It's 90.
I don't know if that means like
Okay, so that was just devising a plan. So Alicia, you had a thought. What did your team think, and what did you come up with?
It is 90 degrees
Okay.
because one of the theorems says that a parallelogram is a rhombus if and only if its diagonals are perpendicular.
And we are told it's a rhombus, so you knew that this was going to form a right angle right there. Excellent. But how can we use that now?
Oh, well, you can set 14a plus 20 equal to 90.
Very good. So we can set this expression, which is shown right here, 14a plus 20, equal to 90, because we know that has to equal 90 degrees, solve for a. But I didn't ask for that. I asked for this angle up here. So what would we have to do after that? Go ahead, Catalina.
When you solve for a, you plug it into 5 and minus 5.
Very good. Once we get a, plug it into that expression, and we get that angle. So go ahead and solve for a, and then find the measure of the angle. Give me a thumbs up when you got it. I know a bunch of you got it already. So just be patient with your classmates and teammates so they have a moment to figure it out. Put your thumbs down.
Oh yeah, yeah,
All right, Daniela, what does a come out to? What is it? 5. A equals 5, and the measure of angle XTZ comes out to what? XTZ comes out to what? Ania?
20 degrees.
It comes out to 20 degrees. And that's what we were looking for. Any questions on how we approached either of these problems? Any concerns about anything? So in continuing the practice I've been using for a while now, I'm going to give you a checkpoint. The checkpoint's going to be related, but it's going to be quite a different slant on the idea. And the point is that I am trying to help you be able to feel comfortable with having to extrapolate what you've learned so far to something new. That's all I'm trying to do, is get you comfortable with, okay, well, here's something totally different. You can do it, so go ahead and give it a shot, okay? So checkpoint number 1. Read carefully, answer the question, make sure you follow instructions, and completely answer the question, okay? So you got 2 questions. They are different. You got 4 minutes on the clock. If you finish before the time is up, then compare your answers with your teammates.
B if they call it. So rough. I am tired too. I started lunch making in December.
So I apologize if it wasn't clear. The sketch should support your reasoning. The sketch that you're drawing for A should support your reasoning for A, and the sketch you draw for B should support your reasoning for B. So two different sketches to support the reasoning. Basically, your sketch should either prove or disprove something. Simple sketch, doesn't need to be complex. Okay, since you got a 50-50 shot, we're going to survey the whole class. So part A, it's either always or sometimes. Give me a thumbs up if you think it's always true. Okay, put your thumbs down. That is always true. Part B, it's either sometimes or always. Give me a thumbs up if it is always. So I assume because nobody put their thumb up that you all think it's sometimes. But now you needed the evidence. So since it's hard for you to speak about a picture, let's just reveal the picture. And this is sometimes because a square is a rhombus. A square is a rhombus. So sometimes Q would equal R, would be congruent to R, sometimes. But if you look at the two pictures, Q will always be congruent to S if it's a rhombus. So that's why A is always and B is sometimes. Does anyone have any questions about what we did there? So very different than what we did in the example. But again, the idea was to take what you've learned and apply it to a different scenario. Any questions about that? I don't know. Okay, glad I could be there for that. So example 2. Again, we're going to continue trying to get comfortable with looking at things very differently. So now we're going to include the idea of the coordinate grid. On this coordinate grid, I have drawn a square. I'm telling you it's a square. You need to sketch out this picture. It's not a big deal using graph paper. And what I would like to do together with you is to show or to prove that the diagonals are two things. The diagonals are congruent to each other and that they're going to form a right angle. So go ahead and take a moment to get the picture down, and then we'll include the new details. So, I'm going to again give you a moment to team talk, but I just want to clarify what we're trying to do. We are trying to prove that the green dotted line that I just drew in here and this green dotted line are actually congruent, that they're exactly the same distance. And I would also like to prove that they cross and form a right angle. So we need evidence. Now, I know that it's a square, and then you can look on the cheat sheet, and the cheat sheet says that they must be. But what I'm saying is, forget about that. Let's show it using the power of the grid. Okay? So that's what we're trying to do. So what I would like you to do is devise two plans. I'm not going to execute the plans, just devise two plans. I want a plan to prove that they're congruent, and I would like a plan to prove that it forms a right angle. So take a minute with your team to discuss and come up with two plans. Go.
Square in half, you get 45. So that and then that's right angle, the diagonal, so correct. And you can prove that's right angle because the slopes of each diagonal are opposite. Plus
All right, let's come back as a whole group. This is not a checkpoint and it's not a team challenge, but we are working as a team to devise a plan. So let's hear what you came up with. Let's talk about congruence first. What plan do you have for proving congruence? So we'll start with Alicia and then Brian. Go ahead. The distance formula. So go ahead, tell me like with what? Okay. Okay. So use the distance formula from here to here. Use the distance formula from here to here. If they're the same, then they're congruent.
Yeah.
Beautiful.
for each diagonal, because they cut the square in half perfectly, they make two 45, 45, 90 triangles.
Okay.
And you can prove that they're both congruent to each other because since all the sides are equal, they have to be the same distance.
So this cuts it into two 45, 45, 90 triangles. And since they share that side, this one has to be congruent to that one. But how do you... Oh, and then you cut this one.
90 cut in half. It's 45.
But we would need to know the distances of all these sides to show that they're all the same.
But you tell us it's a square.
But again, yes, I told you it's a square. We could stop there because we know a square, the diagonals are going to form a right angle. The point was to now show it on the picture. So you're onto something, but I think we would need some information, some numbers in here to show it, okay? But I like the creative approach. Okay, good. So we're going to go ahead as a group, as a whole group, and apply Alicia's plan. And you are going to, with your team, you're going to execute your plan, see if you can show it. Okay? So let's use the distance formula. Distance formula. So we need to show that FH is the same distance as EG. So we need FH, and we need that in the distance formula. Can someone say the distance formula in the really easy way, without having to be like really specific? What's the easy way to say it? Dalton?
The opposite of the x squared is the opposite of the y squared.
Close. Not the opposites. You got to change that word. Zabari? Yeah, the differences of the x's squared plus the differences of the y squared. But you got the basic idea. So here's what the distance formula is. It's the differences of the x's squared plus the differences of the y squared.
Yes, it is.
You have to add the square root.
I apologize. The square root of the differences of the x's plus the differences of the y's. I apologize.
He drew it.
So if we start here, we've got -1 minus 0. So that's -1 minus 0, which is just -1. And then if we do the y's, 3 minus -4, that's a positive 7. And so now simplify that. You don't even need to put it in simplest form as long as it's in an easy form. What would it be if we just simplified it even part of the way or all the way? Anita? It does come out to 5 radical 2. What was it before the 5 radical 2? Yeah, so you could actually leave it like this, or you could say that it's 5 radical 2, absolutely. Okay? So now we need the distance of EG to compare. So, distance formula for EG is the square root of the differences of the x's squared plus the differences of the y's squared. Same process. -4 minus 3 is -7 squared. And -1 minus 0 is -1 squared. Hopefully you can already see. But just taking it to its logical conclusion, we see that it's radical 50 again, or 5 radical 2. And so this is the evidence that we were looking for to show that the two diagonals are congruent to each other. Sorry. So this was the evidence that shows that they are congruent. Any questions about that? Brandon? Okay. What about proving that they form a right angle? What plan did you come up with for that? Start with Anne, and then Sebastian. If we need more help, we'll go to Jada. Anne, what was your plan?
Define the slope of the diagonals to see if they are opposite reciprocals or
Okay. Wow, you really covered everything. That was great. Sebastian? Same exact approach? Okay. Jada, anything different? No. Okay. So let's go ahead and execute that approach. I don't know if we have to go as involved as this. We can just look and say, okay, well, let's do the slope of FH. If I start here and I rise, 1, 2, 3, 4, 5, 6, 7, I see the slope is 7, and then I go -1. So the slope of FH, the slope of FH is 7 over -1.
Yeah.
And then the slope of EG, start at E, rise 1. 1, 2, 3, 4, 5, 6, 7. 1 over 7. So Anne, what did we conclude? That's right. So they're opposite reciprocals. And so they are perpendicular, and they form a right angle. Any comments, questions about that? Brent? Why is it called what? I don't know if I ever looked up why M is used. I'll look it up. I don't know if I ever looked up why. It's a good question. All right. Checkpoint number 2. You, of course, do not need to copy the text of the question, but before we continue, my students in the back, can you see the numbers? Can you see the diagram? Okay, just make sure we can see. This is a 33, that's a 33, that's a 44, that's a 44. Read the questions, answer them, make sure you're answering the questions. Okay? Make sure you're actually writing an answer to the question.
right angles. It's obviously
It doesn't tell you to like a parallel.
it's a parallelogram.
It doesn't tell you to like that. Yep, that.
It just shows the measurement.
It shows the measurement, it doesn't say if it's parallel.
It says right here.
Or
No, hold on.
with theorem, that opposite sides are congruent.
That means if a
Wait, never mind.
So parallelogram.
yeah.
Wait, if a square
Wait,
is
that was
if
a
a triangle of opposite sides are wait, a parallelogram. I'm on number one.
Oh yeah.
Given the measurement in the diagram, given what's in the diagram, and you assume that it's a rectangle. And then in part B, I add some additional information, but beyond that, you can't assume anything. Yeah, right?
Like, you can assume that that's a parallel. You can say that's a parallel.
Quadrilateral is parallel. I think that's yeah, I already know that. Yeah, but a rectangle is a parallelogram. That's proof that it's parallel. I'm saying you have to prove that it's parallelogram for it to be
If you were testing for that shape, you'd say no.
I assume that it is because look.
Okay, we're coming back as a whole group. So we're going to survey again, because part A is really a yes or no question. So give me a thumbs up if you think you can assume that it's a rectangle. Okay, we got a few people who think you can. Okay, good. So unfortunately you cannot. You cannot assume that it's a rectangle. Could someone give me a piece of information that if it was in the diagram, it would make it like super clear that it was a rectangle? Caleb? Okay, so if there was a right angle indicator, even in one or two of the corners, you would be able to figure it out. But since there's nothing there, you cannot assume. I understand it looks like a rectangle, but that's not good enough. Okay? So now, I add in some details. Take the measurements of the diagonals and we get 54.8 and 55.3. What can you say now about the shape? Okay? We got Fung, Sebastian, and then we'll go to Brandon. Okay? Not a rectangle, but you say it's a parallelogram. And, oh, I'm sorry, Brandon? Okay, so you basically took their two conclusions and put them together. And you're all right, because I was pretty open-ended about the question, but I said all of that. I said that it is a parallelogram, but you cannot say that it's a rectangle. And I gotta tell you that this idea that's illustrated in this question is a critical idea out there in our world. Because contractors and home builders and people who build schools, they actually have to spend an incredible amount of time planning out things like this to make sure that the word they use is integrity, that there's integrity in what they're building, because if the integrity is lost, that puts the building at risk of having a huge problem. In other words, if this is not a perfect rectangle, if it's a slightly off, there's pressure being pushed down from above because there's weight, right? If this is a two-story house, there's a ton of weight on that wall. If this is off by a little bit, it's going to start tilting more and more over time. If there's a glass window in here, what's going to happen? It's going to shatter at some point. That's dangerous. And then even more time, the whole wall is going to either collapse or crack or something bad is going to happen. So contractors and home builders and architects take an incredible amount of time and effort to make sure that they are building in as much integrity, as much precision as possible to make sure that we minimize those things from happening. There's no way to eliminate it. Out west in California, they suffer from earthquakes. So if this part of the ground shifts, then the wall's going to shift a little bit, and then the integrity is put in jeopardy. Here in Florida, a lot of our homes are built on swampland. And so that's not very sturdy ground. So they actually had to bring in material and pour it into the swamp to make it more sturdy. Have you ever heard a story, and they're horrifying, but of sinkholes? Mm-hmm. That happens here in Florida. It doesn't really happen in many other places because the ground that our homes are on is not as sturdy as, for example, somewhere in the Midwest. They did their best to try and fortify it and make sure it was strong, but they can't guarantee it. But they take every possible step they can. So any questions about what we've done here? Brandon?
I don't know why, but seeing that makes me so uncomfortable. Because seeing it's not a rectangle. It's just like.
Right. I understand. But again, keep in mind that when they build these things for real, they really make sure. I mean, they use tools and they use a lot of different methods to make sure it's perfect. Okay? Good. Well, we're going right to checkpoint number 3. Because you guys don't need me anymore. You just need to explore a little bit deeper. And so, you got 4 minutes for 2 questions. This is intended as an individual, independent set of questions. But if you need guidance, of course, you can talk to your team.
Many.
Oh, okay, I see that. I see it. Okay. Okay, PR, right? Okay, so that's your practice, right? So that's
I mean, when they
Just imagine yourself singing something.
Oh, I didn't even do that. I did it like a long period. I did 360 minus 70. Divided by 2. And then I divided that
All right.
Yeah.
So we're back as a whole group. So part A, what did you get? I got students 9 and 17 and 20. Student number 9, what'd you get? Okay, student number 17. Student number 20. 42 units, very good. Part B, the measure of angle QRP, I've got student 21, 10, and 4. Student 21. Student 10. Student number 4. It is 51 degrees. Very good. Give me a thumbs up if you got both of those correct. Wow, an incredible amount of success. Put your thumbs down. Anyone have any questions? Brent?
Wait, never mind. Wait.
Okay. So, checkpoint number 4, we're going to finish out with the team challenge. So, write a two-column proof. So, PQTS is a rhombus with PR, and I know the R is a little bit hidden there, but it'll come back in a second. I would like you to prove that QR is congruent to SR. So I would like you to prove that that is congruent to that. Remember, you need to gather evidence to support your conclusion. Okay? Any questions? Got about 8 minutes. That's not really what I'm looking for.
Okay.
Not really what I was looking for.
But could we use it in a future time?
At a future time.
Okay.
There is a fifth here?
You guys don't.
See, look, there's a tree.
No way.
So what do we do for the
There. Huh?
Dude, I see these.
Okay, because you know the PR is a diagram, right? That bisects one of them.
C R P P E T. Hold up. Yes,
I
ma'am.
don't know. I think you are seeing
And then if you add them together, it's going.
All right. Well, I had intended more time, but I'm very short on time, so we're going to wrap up this team challenge. I will reveal my proof, and some of you were successful, some of you didn't have enough time, but I want to just maybe see if I can open your eyes to something. So if we took the approach of proving these two triangles were congruent, once you prove triangles are congruent by CP, CTC, you can say that any corresponding parts are congruent. So I can prove, we already know that that's congruent to that. That's one piece of evidence. This side is congruent to itself. That's two pieces of evidence. This angle is congruent to that angle because of the fact that it's a rhombus and the the diagonals bisect the angle, so now I have side, angle, side. So by proving that the triangles are congruent, we can now say that QR is congruent to SR. And so that's the approach that I took. That is certainly not the only way to do it, but here is my proof. And some of you have been kind of wondering, how do I write these theorems out when Mr. Gallett's saying don't use the names? Well, you use shorthand. If a quadrilateral is a rhombus, then each diagonal bisects the opposite angles. If a quadrilateral is a rhombus, then all sides are congruent. So that's a short way of writing. Okay? So I wanted to spend more time on this. I apologize for that. I need to wrap up so that you guys can get to your next class. Your homework is page 531. You're doing numbers 19 through 29, 32 to 51, and 54 A and B. It does work out to 33 points, so there is a bit going on here, but it's not beyond your abilities. And then the next assessment you're going to have is your quarterly exam, which will be next week.